Hey, this video is about how UnityEngine works. It's an overview and I hope it will be helpful for anyone wondering should I learn Unity to make games. So here goes nothing. The original idea behind Unity was to use a component-based architecture, an entity component system, but in a simplified form. So over time Unity has drifted away from this concept quite a bit. In Unity, everything in a scene is made up of objects, and their behavior is defined by attaching components. You literally build each object out of small functional pieces like Lego. Though, in practice, this approach is mostly used by beginners. At a professional level, developers usually build their own architecture on top. This system gives you flexibility, simplicity, and modularity. As a result, Unity became approachable and easy to learn, and that's why for a long time it was the most popular game engine. Like any engine, Unity provides its own libraries, essentially a collection of classes you will be working with. UnityEngine is the main library that contains the core classes and submodules for making games. GameObject, Transform, Rigidbody, it's all here. And that's why you almost always see using UnityEngine at the top of your scripts. Besides the main part, UnityEngine includes several namespaces, like UI, scene management, input system, and events. UnityEditor is a separate library for creating custom development tools. It doesn't get included in your final build. It only works inside the editor. Anything related to custom inspectors, editor windows, asset generation, or automation is done through this. If you ever bought a plugin from the asset store, chances are it uses UnityEditor. Scripts that use this library are wrapped in the if UnityEditor directive to make sure they don't end up in the actual game. From a technical standpoint, a scene in Unity is just a file with the .unity extension. This file is a serialized YAML structure that stores all objects, their components, parameters, and relationships. Internally, it's a list of entries where each object knows who its parent is. Unity uses these links to build the hierarchy you see in the hierarchy window. So, visually, it looks like a tree, but under the hood, it's more like a list with the IDs and references. In the engine, a scene acts like a level or a screen. You might have one scene for gameplay, another for main menu, or a background scene with the environment elements. Unity lets you upload scenes either one at a time or in parallel. For example, you can upload UI scene on top of the main gameplay scene. That's handled by Scene Manager. Inside the scene, objects are arranged like a list, and this isn't just a visual list, it's a real structure where one object can be the parent of another. For example, if you parent a sword to a character's hand, it becomes a child object and will follow all of the parent's movement and rotation. A game object is a basic type of object in Unity scene. On its own, a game object is just a container. It doesn't do anything and has no appearance until you add components to it. A component is a functional model that adds specific capabilities to the object. For example, Transform handles position, rotation, and scale. Mesh Renderer makes a 3D object visible. It displays the model if the object has a mesh filter and a material. Rigidbody enables physics simulation. Audio source lets the object play sound. The script you write yourself, if they inherit from MonoBehaviour, we will get to that later, are also components. You can attach them to game objects. They appear in the inspector and Unity runs them automatically. They call methods like start, upload, respond to events, and control game logic. Every game object always has a transform component. It's the bare minimum. Even if you create an empty object, transform will be there, because Unity needs to know where that object is in the world. So you are literally building a functional game object out of little models, and since components can be reused, you can build lots of similar objects out of the same parts. That's quite convenient. A prefab is the object template. You create a game object with all components you need, configure it once, and save it as a prefab. Now you can clone it as many times as you want in any scene, anywhere. It's essentially a prototype template implemented on the engine level. When you place a prefab into a scene, all of its components and settings stay intact. If you later modify the original prefab, Unity will automatically update all of its instances. That's also quite convenient. For example, if you have 100 of identical enemies, you can change their speed all at once. Instancing is the process of creating those copies during gameplay. Say you shoot and a bullet prefab gets spawned into the scene, or enemies appear out of nowhere. That's prefab instancing too. Just make sure to use object pooling so your game keeps running smoothly and doesn't choke on memory allocation. MonoBehaviour is a base class for custom components in Unity. Only classes that inherit from it can be attached to GameObjects. They show up in the inspector and become part of the gameplay logic. This is possible thanks to Unity's serialization and reflection systems. The engine can save and restore field values, detect specific method names like start or update, and call them automatically at the right time. These methods become the entry point of object's lifecycle. Awake is called once when the object is loaded. Use it for initialization that doesn't depend on other objects. Start runs after awake, typically used when you need to access other components. Fixed update runs at fixed time intervals and is synced with the PhysX engine. Update is called every frame. This is where your main gameplay logic goes. Late update is called at the end of the frame after all update calls. It's useful for reacting to changes. For example, adjusting the camera after a character has moved. The important thing, update depends on frame rate, while fixed update runs on a steady timer. That's important for predictable physics. Anything using Rigidbody usually belongs to fixed update. To calculate time between frames, Unity uses time delta time. It tells you how much time has passed since the last frame and makes movement and animation consistent, regardless of FPS. Unity uses NVIDIA physics for 3D physics and Box 2D for 2D. To tell Unity that an object should behave physically, you add Rigidbody component. It enables gravity and lets you move the object using physical forces. Without a rigid body, an object is treated as static. It won't move on its own, but it can still block other physical bodies if it has a collider. A collider defines the object's physics shape. This is important for handling collisions, since a 3D model by itself is just a visual. It doesn't have any physical presence. Colliders can be simple, like box collider or sphere collider, or complex, like mesh collider. A collider can work in two modes. If a trigger is on, it becomes a trigger zone. Object can pass through, and Unity calls on trigger enter, on trigger exit, on trigger stay. If is trigger is off, the collider acts as a solid body, and Unity uses on collision enter, on collision exit, on collision stay instead. One important note, at least one object needs a rigid body for any of this to work. Otherwise, Unity won't register collision at all. Unity's user interface is built on a separate level centered around the canvas component. All UI elements are placed inside the canvas, and their position in the list directly affects what is drawn on top. All interface elements like text, button, or image are just regular game objects, but instead of a transform, they use a React transform. This allows them to anchor to screen edges, scale with resolution, and position themselves in screen space. The canvas can operate in three modes. Screen space overlay, UI is drawn over everything independent of any camera. Screen space camera attaches the UI to a specific camera and renders it using that camera's settings. This gives you more control over scaling and perspective and allows you to use camera effects on the UI. World space. UI elements become part of the 3D world. You can move, rotate, and scale them like any object. To handle user input, Unity uses the event system. This component is automatically added when you create your first UI element and listen for interaction events like clicks, focus, or hovering. Unity uses several systems to handle user input: event system, Unity event, and either the legacy input manager or the newest input system. Event system is a component that tracks user actions like clicks, touches, pointer movement, and switching between UI elements. Without it, UI buttons and other elements won't respond to interaction. To handle UI interactions, Unity uses Unity events, a serializable event, meaning Unity can save it in this scene and expose it in the inspector. You can link link a method to a button click directly from the editor without writing any code. This is especially useful in prefabs for quickly wiring up logic. In code, you can subscribe to a Unity event using a listener. It works similarly to standard C# events, but with some key difference. Unity events support editor interaction, can be serialized, and are easy to set up visually. In contrast, regular C# events are more performant and give you tighter control in code, but they can't be edited in the inspector and aren't serialized. For general game input like movement, shooting, or jumping, Unity offers two systems. Legacy Input Manager uses calls like input-get-key or input-get-access. It's a simple and works out of the box, but doesn't scale well and has limited support for controllers. And new input system. It's configured through an input action asset, support multiple devices, remapping, events, and is designed with the cross-platform use in mind. It requires a bit more setup, but is more convenient in the long term. ScriptableObject is a type of Unity object used to store data outside of the scenes and game objects. Unlike MonoBehaviour, it doesn't need to be attached to anything. You create a scriptable object as a separate asset file. Unity saves it as a .asset. It's useful for things like configuration files, enemy stats, item definitions, dialog lines, anything you want to decouple from scene logic. This helps separate data from behavior, and the same asset can be reused across multiple scenes. If you worked with JSON, you can think of ScriptableObject as a built-in alternative, but strongly typed and editor-friendly. The main difference is ScriptableObject is a native Unity object. They show up in the inspector, support custom editors, and can reference other Unity assets like sprites or audio clips. JSON is just a plain text. You have to manually parse it and can't plug in directly into the scene. You can also use ScriptableObject to store global settings, random state, cross-scene data, or even implement event system. When your game is ready, you need to compile it into an executable build. In Unity, this is done through the build setting window. Here you select a target platform. Unity will automatically include the required modules, re-import the assets, and compile the project for that platform. You also need to explicitly add the scenes you want to include in the build. Only those will be backed. This is also where you set up the startup scene, processor architecture, compression options, and output path. Under the hood, Unity compiles your scripts into common intermediate language, converts your assets into internal formats like .asset, .bundle, and so on, and packs everything into a folder with an executable. If you need to load content outside the main build, you can use assets bundle or the newer addressable system. They allow you to keep assets separate, load them over the network, cache them, and update them without rebuilding the entire game. The asset pipeline is a system Unity uses to process the import all assets in your project. Images, FBX models, sounds, animations, fonts, and so on. When you add a file to your project, Unity doesn't use it directly. Instead, it creates a .meta file with a unique ID and converts the asset into its own internal format. This process is called importing. Why does Unity do this? It allows the engine to speed up scene and project loading, cache resources, manage dependencies and references, and reuse assets across different platforms. If you change the source file, Unity will automatically re-import it. This makes it easier to update assets and keep workflows smooth between designers, artists, and programmers. The visual appearance of objects in Unity is defined by material, lighting, and shaders. Light is a component that emits light. Unity supports several types: directional, point, spot, and area. Lighting can be real-time or baked. Unity also supports ambient light, global illumination, and shadow maps. Material is what's worn on the surface of an object. It controls color, texture, transparency, reflections, and other visual properties. Each mesh renderer renderer or sprite renderer uses a material to know how to render the object. Shader is a small program that defines how pixels appear on the screen. Unity uses the standard shader by default, but you can also use URP, HDRP, custom shaders, or shader graph. Unity has a built-in way to store simple data between sessions. It's called PlayerPrefs. You can use it to save things like settings, player progress, high scores, or other basic data like numbers and strings. Just keep in mind, PlayerPrefs are not encrypted and can be easily accessed from outside the game. So they are best for non-sensitive data. For more complex or secure saving, developers usually serialize data to JSON or binary files and store them manually. Well, that was a long one, but I hope it helped you to better understand how Unity works under the hood. I poured a lot of effort into this video, and honestly, I'm exhausted. So if you find it useful, consider subscribing. Thanks for watching, and see you in the next one.